Hello friends, welcome to Sarat Chandra IAS Academy, where your dreams are our mission. This is Yatharth here, and today we are going to talk about nuclear minerals and India. In this part, we'll be dealing with the basic knowledge, the NCERT, PYQs, the complete mapping related to this topic, and we'll try to answer all your questions in this lecture. Alright, let's move forward. Now, first of all, let us see what was the question in the prelims this year. I'll highlight the important pickups from this question. So it says in statement 1, it gives us two statements. In the statement 1, it says that India, despite having uranium deposits, depends on coal for most of its electricity production. So it's saying that India has uranium. Second thing, it says that India depends on coal for most of its electricity production. And this statement is regardless of the first thing. That means despite having this, India still depends on this. So is this true or not? So this is the first thing. The second thing is that uranium enriched to the extent of at least 60% is required for the production of electricity. So this is the second statement. So we need to know what is uranium enrichment. Then we need to be certain about the percentage, that how much is required for electricity production, how much is required for the weapon grade uranium, and what is enrichment. So these two statements, just a second. All right. Further, the question asks us to ascertain that both statements, basically what is the relation between the statements. So we need to mark correctly here as well after carefully reading the options. So let us address this topic from the very root, from the very basic, so that even the new students, new aspirants who are seeing this may take a complete hint for how to solve these type of questions, even in the further exams, no matter what is asked. So we'll be dealing with both science and tech portion here, as well as the geography portion here, that is Indian geography. We'll also know what is uranium, what is thorium, what is monazite, and we'll deal with the 2022's question as well, where monazite was asked. Alright, so let's start the topic. So what is the subject and topic? Main subject is Indian geography here, mineral resources of India. Earlier also one question has been asked in the same paper about the titanium ore, ilmenite, rutile, etc. So that was given in NCERT, TiO2. Okay, to be used in toothpaste. Anyway, so mineral resources in India and energy production and its methods. So it's asking us about electricity generation as well, primarily. The sources, whether we are using coal or nuclear. We have already covered this topic. Please, you can watch our video. Is India phasing out nuclear reactors? So this was covered. Anyway, let's do it again from the very basic. So first of all, the question that comes, that what does it mean to be nuclear? We keep using this word nuclear. Now, what does it mean to be nuclear? So anything that deals with the nucleus of an atom or some specific type of atoms is told as nuclear, said as nuclear. Let's say nuclear physics, nuclear chemistry, nuclear anything else. Alright, so a study of the nucleus. Nuclear reaction, so reactions that involve the nucleus of any atom. So what is nucleus again? We need to be sure about this as well. And what's part of an atom is known as nucleus. So let's say this is an atom. This is a hypothetical model. Whenever we talk about atom in the basic physics or basic chemistry model, then this is a hypothetical model of atom that we propose. But this is not how it has been devised in the quantum physics. Alright, in the quantum physics, it has been devised as, this line has been devised as a hypothetical line based out of probabilities. So that we'll discuss some other day. Right now, let's just go with the classical model. So in the classical model, this is how an atom looks like. And in the core of the atom, there it is supposed that there is a nucleus. Alright, this is a nucleus and it consists of both proton and neutrons, both bound by nuclear forces, which is the strongest force of all forces in the universe. Please remember this. When we talk about the gravitational force, it may seem like the strongest force of the universe, but it is actually the weakest. There are also electrostatic forces, there is magnetic forces, and there is nuclear forces. So nuclear are the strongest force. Alright, so much may not be asked in the exam, but of course UPSC is again unpredictable. It may or may not ask anything. So the nucleus contains primarily of the protons, the neutrons, and the electrons are not a part of nucleus. Electrons are outside of the nucleus in various different electron orbits. So we don't need to go out further in what is orbit, what is orbital. That is a chemistry topic. So we'll not deal with that. We'll just stick to the nucleus. So nucleus contains both protons and neutrons. Protons are positively charged particles and neutrons are neutral, zero charge particles, but they have the same weight. Alright, let's further move to when we say the specific type of atoms. So the term nuclear typically implies the involvement of radioactivity or nuclear reactions. Let us see what do we mean by radioactivity, or what does radioactivity mean? There's this word radio plus activity. So we'll see about this. The term nuclear specifically refers to the utilization of materials that undergo nuclear reactions. So they have to be active. They have to be dynamic. Alright. Such as nuclear fission or nuclear fusion. So these are two types of nuclear reactions. We'll read about them as well. So these reactions involve the splitting or combining of atomic nuclei, resulting in the release of a significant amount of energy. This energy is very important for us, as ultimately this is the energy that we use in both electricity production as well as nuclear weapons. Alright, so we'll see how does this energy come. So let's first talk about the radioactivity. So radioactivity is a natural phenomena. Please understand this first thing, that occurs in certain substances where they emit tiny, invisible particles and energy. Please remember all these terms, they can be part of the option. And when the option comes like this, we get confused. We need to be sure whether they are tiny, whether they are invisible. Alright, so we may get confused if we say that the photons are released, let's say. Now photons are visible. Okay, so these substances are often referred to as radioactive or radioactive materials. In stable atoms, radioactivity is not found because the nucleus is balanced and stable and does not want to change. However, in radioactive atoms, the nucleus is unstable and wants to change. It wants to change its configuration or overall energy. It wants to either release energy or get some energy for its own bonding. To become more stable, the unstable nucleus releases excess energy in the form of radiation. This is known as radioactivity. So what does it release as radiation? Are three types of particle. Primarily they are alpha, beta and gamma particles. So just a second. So these are three types of particle: alpha particle, beta particle and gamma particle. They have different configuration, such as alpha particle, they have 2 protons and 2 neutrons. 2 protons, 2 neutrons. Alright, basically 2 He plus. Then there is beta particle, they have high energy electron or positrons. So they are either E minus or P plus. Positrons are antiparticle of the electrons. Then there is gamma particle, they are high energy electromagnetic waves. So they have both electric field as well as magnetic field. Both are directed at 90 degrees of each other. Alright, so photons are also electromagnetic waves, light basically. Okay. So when these particle and rays are released, they can travel through the air and materials around them. They can penetrate also some solid liquids and gases. Radioactivity can occur naturally in certain elements found in rock, soil and even our body, such as uranium and potassium. Please remember potassium as well. All right. So let's move forward. So this the question that if they are so unstable, then how are they formed in the first place? Why are they found like this? Why uranium came to be if it was so unstable? So the answer lies in the cosmic realities. So first of all, what might have happened before the Big Bang? We don't know. There could be a possibly shrinking or expanding universe which resulted into the Big Bang. Now from the Big Bang, only the lightest elements were formed initially, like hydrogen and helium. These heavier elements like uranium are not created during the initial stages of the universe. The formation of uranium primarily occurred in the later stage. So please remember this fact as well. Within massive stars, these stars go through a series of fusion reactions, where hydrogen fused to form helium and helium further fused to form heavier elements. At the stellar core, that means at the core of, let's say, stars, heavy stars, it eventually reached temperature and pressure that enable the synthesis of uranium. So high pressure and high temperature is required for nuclear fusion. Please remember. All right. So this happened at the core of stars, like let's say the sun. Sun is one of the medium or smaller stars even. Okay, so during the final stage of the massive star's life, there is an explosion called a supernova. That is when these heavier atoms get released in the universe. Universal dust, let's say. Okay. So these ejected materials then disperse and mix with interstellar gas and dust. Over time, these enriched interstellar clouds of gas and dust can collapse under gravity, forming new stars and planetary systems. The presence of uranium in these regions allow for the formation of planets that contain uranium within the composition, including Earth. So whenever Earth might have formed from the universal gases and dust under the action of gravity, then let's say if the uranium was supposed to be deposited here, or wherever else, then it got deposited on the final surfaces. So India also does have these reserves, fortunately. Okay. So let's move further. This is how uranium came to be in the first place, or deposited in the earth. So whenever we talk about Earth, we should also think where Earth initially came from. So it came from universal gases and dust, where these elements were initially formed. So please remember this also. Further, we learnt that uranium or such elements are unstable. They want to release excess energy, which they got because of high temperature, pressure in the stellar core. So due to this release of energy, they term radioactive. And they keep releasing various particles such as alpha, beta and gamma particle. Alright, so this is the basics of nuclear fusion and fission. This activity is known as radioactivity or nuclear fission. Now let us come to what are fission and fusion and what are the differences between them. So as we previously talked about, nuclear fusion is a process in which two light atomic nuclei, which were initially formed, hydrogen or helium, typically isotopes of hydrogen, combine or fuse together to form a heavier nucleus. This fusion process releases a tremendous amount of energy. It is the fundamental process that powers the sun and other stars, where hydrogen nuclei fuse to form helium. So in nuclear fusion, on the other end, the reverse process happens when a heavier nucleus disintegrates into lighter nucleus, such as the light atomic nuclei must overcome their mutual electrostatic repulsion. So this is the detail, we don't need to read it, to get close enough for the strong nuclear force to bind them together. Achieving the required condition for fusion requires extremely high temperatures and pressures. The high temperature causes the atoms to be in a highly energetic state known as plasma, where electrons are separated from the atomic nuclei. So this is basically about the fusion. Let me tell you the same thing here. So we started with the lighter elements such as hydrogen and helium, or their isotopes. So they need to get together. And in order for them to get together, they must overcome their mutual repulsion. There is a repulsion between, let's say, proton and proton, because they are both positively charged. And the kind of repulsion here is not only electrostatic, but also nuclear repulsion. This force can be overcome, they can be bound together by high energy and high temperature and pressure. This is the energy that get collected into them eventually. This only takes place at the core of the stars. It needs very, very high energy and pressure basically. And this energy is eventually released when these atom binding takes place, when these protons bind with each other. So it releases a lot more energy than the fission, and it powers the stars like sun. So please remember this fact that both the fusion and the fission release energy. Both the fusion and fission release energy. And the energy released by fusion is more than the fission. Okay. So there are different types of nuclear fusion reactions, but the most common one involves the fusion of isotopes of hydrogen. So we don't need to go in this detail. You can take the screenshot and read. Deuterium and tritium are mostly involved here, and they produce helium-like atoms, elements, and their high energy neutrons as byproducts. So this releases an enormous amount of energy, and this is based on Einstein's mass energy conservation, E is equal to mc square. Okay, so where is a small amount of mass is converted into large amount of energy. So there are some reactors which are being developed on Earth also, tokamak reactors, etc., which are trying for this. China is actively trying to achieve the nuclear fusion reaction on Earth. All right, so we'll read about this later on. Just to read that tokamak and stellarators. So these are both used for nuclear fusion, imitating nuclear fusion. So this is nuclear fusion, you can see here. Deuterium and tritium, they fuse to release energy and release helium and neutron. Okay, let's talk about the fission now. So fission is what we are going to talk about mostly today. So fission is a process in which the nucleus of an atom, typically heavy atom like uranium-235 or plutonium, is split over into two or more smaller nuclei, along with the release of large amount of energy. This process can occur spontaneously or can be induced by bombarding a nucleus with a neutron, so make it more unstable. So when a heavy nucleus undergoes fission, it becomes unstable and split into two smaller nuclei. So this is what we use for the electricity production also. These fragments are accompanied by release of several high-speed neutrons and a significant amount of energy. So at both places, energy is being released. This even can cause a chain reaction because more neutrons are being released and they will strike more unstable uranium nucleus. Alright, so this is what we use in nuclear fission. So the energy released during nuclear fission is immense, and it can be harnessed and used for various applications such as generating electricity in nuclear power plants. It is used in commercial nuclear power plants to produce electricity. The process involves controlling the chain reaction by moderators such as water or graphite to slow down the neutrons, and control rods made of materials like boron or cadmium. Please remember these materials also, that boron and cadmium are used in the control rods. This is an important fact that can come directly as a question. Please remember these, boron and cadmium. Recently the question came on cobalt this year. Alright, so please note these down. So which absorb neutrons and regulate the rate of the reaction. Nuclear fission also plays a crucial role in development of nuclear weapons. Let's come here and see. So this is a neutron. We bombard it upon the uranium-235 nucleus, releases 200 mega electron volt of energy and disintegrates into 3 neutrons. And this is krypton and barium. Okay. What is 1 electron volt EV? Let us see this also. It is a physics term. We don't really need to read it, but for the sake of curiosity. So when there is a potential difference of 1 volt, so electron is transferred from here to here, let's say. So here to here, let's say. So it gains some energy, and that energy is equal to 1 electron volt. Mega means 10 to the power 6 of this So it's a very small unit, not very big. Sorry, just a second. Okay. One more thing we need to know, that how is eventually electricity made from these nuclear fission reactions. So this is how it works. Such as the nuclear reaction takes place here, control rods, etc. This is reaction pressure vessel, and it boils the cool water that is pumped from here. So this is the cool water. So the energy is finally conducted into this water, and it produces steam. That steam is flowed through here, and it moves these turbines mechanically. So which three energies or form of energies does this process combine? It combines heat energy, transfer by the heat energy, then transfer of energy by the mechanical energy, and then transfer of energy or conversion of energy from the mechanical to electric generator. So magnetic energy is also used here along with the electrostatic. So almost all of the forms of energies are used in this process. Finally, this is transferred to grids and eventually to houses. This warm water or whatever water is remaining here is either sent back to condenser or released, the wastewater is released into seas, which can be a cause of pollution. This is one of the big, that's a controversies going around in the Kundakulam plant here in the Tamil Nadu. So we'll see about that someday else. Let us now come to what are uranium, thorium and monazite.